the note. We will have a 30 minutes or less at the end of the session for your questions. Thank you.
Thank you, Mohammed. So we start now?
Yes, Prof. The floor is yours. You can proceed now.
Yeah, okay. Thank you very much for inviting me to participate or to present this topic to your members in the International Farm Student Federation. Yeah, my topic, research methodology and study designs. I will cover this topic by reviewing some screenshot from published research papers resembling examples of designs, including cross-sectional, longitudinal, case control cohort, and randomized control trials. And during this review, I will talk about certain types of analysis and certain types of like statistical tests and how data can be presented. So I want to use a different approach, not to just talk about the design in the classical way. So first, I will talk about the main types of designs commonly used in research, based on whether there is intervention or not, or no intervention. Designs can be divided into observational or experimental. Observational can be descriptive or analytic, based on whether there is a comparison group or no. Descriptive studies include cross-sectional and case report, case series, and so on. Analytical studies based on direction of exposure. We have 3 examples: cohort, case control, and cross-sectional. Also, here, cross-sectional as analytical study when we are looking into relationship between exposure and outcome. In this case, both exposure and outcomes are measured in the same time, while in case control study, we start with outcome like disease, and then we go back to assess exposure. In cohort study, we start with exposure and go forward to see what outcomes occur. For experimental study designs, the main design which is very common use and very famous is randomized control trial. And this is based on whether there is randomization or no. If there is no randomization, we have non-randomized control trial. Of course, there are other experimental designs other than those appear here. For example, we have pseudo-randomized, and we have also quasi-experimental. Here, the difference in randomized control trial, we have randomization by subject, while in quasi-experimental, randomization is by groups, what is called clusters. And we have also pseudo-randomized trial when selection of subject and randomization is based on like consequence of entering the study, like saying that the first subject will be treatment and the second subject will be control or comparative group, and then consequently consequently when subject is come according to the sequence, third one will be treatment, fourth one will be control, and so on. This is called pseudo-randomized. And also there is non-randomized control trial. I will give examples. This another also flow chart or figure to describe the categorization. It is not much different from what I just talked now. And regarding case control and cohort and also cross-sectional, we have based on when we start collecting the data, if we have here in the circle today, if we go forward in the future, this represent cohort. And if we go back to the past, it is case control. Here, of course, for case control, you start with cases and then go back in the past to see the factors of exposure, which is represent maybe factor for having the disease. And cohort, we go forward from today to the future to see the outcomes. And if the data only collected today, what already available, either prospective or retrospective, like using survey, and this may represent cross-sectional study. We have also historical cohort, which is like cohort in the direction. That means we go in the same direction, but we start from the past, then we go till we reach today, or maybe we extend to the future. The first example here of cross-sectional, I will start to show some examples representing cross-sectional studies first. This study, suspected adverse drug reaction reported for Brazilian children, cross-sectional study. I want just to focus on certain issues related to this study. Here, for example, this abstract of the study, they say that the study was carried out for 6-year period, 2008 till 2013, and this represents the period of data collection. Actually, there is one issue that some may confuse about when we have data collected over a period of time. This 2008 till 2013 is still cross-sectional study, but the data collected covers this period. While for other designs like longitudinal studies or cohort studies where there is follow-up, the data collection may cover also a long period of time, but the difference here is that there is continuous measurement for the same units, observation, regarding the same unit of study over time to see change in certain characteristic or to see outcomes, certain outcomes. But here, because all subjects, including the study, were presented during this period, 2008 to 2013, and every unit is measured or observed once, so it is cross-sectional still. Here, how data is presented. Normal descriptive presentation of statistic is to show frequencies and percentage. We have here the years. Those are the cases during the different years, frequencies, and then percentage. And this normal type of presentation. We will see also another type of presentation in other examples. This is the same study, the first study, and here also, here data is presented graphically using line graphs. And normally, line graphs are used to reflect pattern of data or pattern of observation over either over a period of time or to show difference between between groups, different rates of something. So it is good to use line graphs. Another study, cross-sectional, I will continue like this. Every study focus on something, like how data presented, what statistical test used, and how that collected, and so on, to show the variation in methodologies. But all my examples first will be cross-sectional. Then I will provide also examples of longitudinal studies, and also examples of case control, and also then example of cohort and randomized clinical trials. Here, this is study kidney function and use of non-steroidal anti-inflammatory drugs among elderly people. This cross-sectional study just talk about potential hazard for an at-risk population. Here they want to estimate risk, so we can see that they used linear regression analysis. They use linear regression analysis. Here, the study before, they just present data descriptively, but here it is considered like inferential statistic, because there is difference between the design itself and how data is presented. We have in a statistic, either we present the data or analyze the data descriptively, just show frequencies, percentage, mean, and so on of the sample, or we use inferential statistic, and this includes estimation, or like also testing hypothesis. And one of those, like here, estimating risk, or here they use linear regression. Regression, one of the types of regression, we have linear and we have logistic regression. Normally, linear regression is used when the outcome is continuous variable. The outcome, because normally we are looking into relationship between variable and another variable. One variable is independent and one is dependent. And if the dependent variable is continuous variable, we use linear regression. If the outcome is dichotomous categorical variable, we use logistic regression. So here, this example, they use linear regression. The same study, here's the table of table 2 about background characteristic of study population. And we can see here they use mean and standard deviation. This part is descriptive presentation. And also they have frequencies and proportions. That means percentage. We see here sometimes for frequencies, when they present observations under certain subgroup, they show the total number, like here, male, 1,000, out of 1,798 are males, which represents 56%. Here, why they show 1,798? Because there is or there are some missing data, some information are missing. Not all the total, I mean the total number of observation are not the same. If the total number of observation are the same, we don't need to show this 1,798, because here, for example, sometimes the total is 100,712 and so on. 1,782. So this means because there is some missing. That means not all the total number of subjects have complete data. And for this also, I want just to make comment. Normally, cross-sectional studies can be prospective, can be retrospective. Retrospective means that the data is collected from record from the past, something already recorded data, the researcher collects the data from record, and when it is prospective, that means the researcher is observing and collecting data freshly occurring. One advantage of prospective is that we avoid missing data, because we can try to focus and to try not to have something missing. But something already in record, if it is missing, so we don't have to do, that means we can't do anything. Just when we present, we show the total number of observations. Actually, if the missing data is so much, it will be a problem. This study, another one, is mortality from adverse drug reaction related to hospitalization in Southwest Ethiopia. Cross-sectional study. Still, we are talking about cross-sectional studies. And this is talking about mortality rate. Mortality rate. It is estimating mortality rate. Another slide is about part of the result of this study. Here the researcher mentioned of 1,001 patients, 15 representing 1.5 died with an adverse drug reaction. So this 1.5% is rate of death due to adverse drug reaction. And between two brackets, they have 95% confidence interval. 0.8% to 2.3%. This is what confidence interval it is used when we use or present inferential statistics. Because as I said before, just now, we have descriptive statistic, we have inferential. Descriptive, just describing what the researcher observed in the sample. And inferential, try to make inference to the population. And for inferential, either we have estimation or we have hypothesis testing. For estimation, any estimated figure or estimated number, like this one is rate of death due to adverse drug reaction. If we want to make inferential statistic, not talking about the sample, but talking about the population, we have to present the 95% confidence interval. That means the researcher is 95% confident that the true rate of death due to adverse drug reaction in the population will be between 0.8 to 2.3%. That means the lower limit and upper limit of the estimation. Normally, in this part, in this slide, I want just to focus on confidence interval. Normal confidence interval, we can get a lot of information from confidence interval. If the confidence interval limits or the difference between lower and upper limit is narrow, we call that this confidence interval is, or this estimation is precise estimation. And precision in estimation is reflection of sample size. That means when we use large sample size, it will be reflected on precision of confidence interval. That means the confidence interval will be as narrow as possible. That means, for example, if we have more precise confidence interval than this one here in this study, it will be maybe the limits instead of 0.8 will be, for example, 1 to 2. So 1 to 2 will be more precise. Also, confidence interval normally can indicate whether the differences are significant or not. This is when we have the confidence interval of estimated difference between two observations. There will be example, inshallah, and we will focus on it to show how or what I mean by this. Here, this is flow chart used in this study. Here, when I present the title of the study and show any table or figure, it represents, it is related to this study, and unless another study comes. Here, this flow chart is used to show how subjects have been selected or recruited. and divide it into groups and subgroups. Just I want to make comment about flowchart in papers normally is used either to show how samples have been selected or to also to reflect inclusion and exclusion criteria and how many subjects included, how many subjects excluded. And we have criteria like PRISMA, which is used in systematic review, and also we have like CONSORT in randomized control trials, which requires that flowchart be used. But here for like this cross-sectional study, it is not mandatory. It is just optional for the researcher. This table is under the same study. Here they show confidence interval of some estimate of differences. For example, they present they have variable highlighted in yellow, previous adverse drug reaction history, number and percentage between two brackets, because they have two groups: patient alive without adverse drug reaction and patient died with adverse drug reaction. Then they compare. For example, here the previous adverse drug reaction history represent 40% among patient died, although patients who died are only 6 have this character out of 15, so 40%, while patient alive without this reaction represent only 1.4 because they are 11 out of 797. The important thing is that the difference between proportion or means, because some of those variables expressed as proportion or percentage, and some are presented as means. This one is percentage. So the difference is 38% different. So because it is estimation or estimate, they present confidence interval at 5% confidence interval, which is here 13.8 to 63.4. I will comment about how confidence interval can indicate significant difference or not. Here, the difference between proportion of patients who have previous adverse drug reaction history among patient died compared to patient alive, the difference is significant because the confidence interval here, without even seeing the p-value, the confidence interval is all have value above zero. Value above zero from 13.8 to 63.4. But if we see, for example, the figure above it, just above it, which represents the percentage of female, when they compare female between the two groups, they found that female represent 46% among those who died with adverse reaction and 45% among those who alive. And the difference is 1.5. But when they come to the confidence interval, it is minus to 23.9 to 26.9. We see the lower limit is in the negative side, while the upper limit is the positive side. So this means this confidence interval includes zero, and this indicates that this difference is not significant. So if we are talking about confidence interval of difference in percentage or any difference, it should not include zero to be significant. If we have lower limit negative and upper limit positive, that means it includes zero and it is not significant. But for significant differences, either both lower and upper limit be in the negative side or in the positive side. And we will see another example later on when we talk about odds ratio, about also confidence interval of odds ratio. But let us move. Here, I want to also comment about the statistical test used. For example, when they compare percentage, if the percentage, because they are comparing proportion among two groups. Statistical test used can be chi-square normally. And when they are talking about mean, estimating difference in mean, the standard statistical test used normally is student t-test. This one, the first choice. Okay. Another option instead of t-test, student t-test, that can be used is one-way ANOVA. ANOVA is used when we compare mean of certain any characteristic between more than two groups. We use ANOVA. If between two groups, we use student t-test. And there are some options, alternative, instead of t-test ANOVA, when the groups are like related or not related, and also when they are not normally distributed and so on. We will see examples later on. This one is another study, which is still cross-sectional, predictors of adverse reaction related to hospitalization in Southwest Ethiopia. This prospective cross-sectional study. So as I said, cross-sectional can be retrospective, can be prospective, because this depends on how the data is collected. Prospective is preferred than retrospective. Also, as I said, one of the limitations of retrospective, most of the examples we see before were retrospective. One of the limitations of retrospective is a lot of missing data, and also we are not very sure about accuracy of measurement, and because also data is not collected for the purpose of the study. Maybe the data is recorded for clinical reason, like patient record and so on. But here, when the data is collected prospectively, so the researcher himself will collect the data for the purpose of the study. So he will be sure that observations are accurate, and also that means the validity of data will be more, and also they will be sure that no missing data, or at least missing data are as minimum as possible. Here they cover period from May 2015 to August 2016, but still it is cross-sectional, because as I said, the unit of observation have been observed or measured once, only once. If it is measured more than once, it will be longitudinal, or in if it is one is exposed to one outcome, will be like cohort study. Here they have also a flow chart to show or to reflect excluded cases and included cases and so on. And they end by the comparative group. Those groups, they are going to compare when they present the data. We see here, there is table. They compare non-adverse drug reaction group and adverse drug reaction group, and they have here, they show the p-values instead of confidence interval. Normally, to indicate significance, either we have to use confidence interval or p-value. P-value actually represent probability of error in our finding or estimate. That means when the p-value is less than 0.05, that means probability of that there is an error in this observation or estimation or difference and so on is less than 0.05. Here we have another example, cross-sectional study, knowledge and attitude towards medication error among pharmacists. And this type of study is just survey. When we come to tools used for data collection, all those are cross-sectional, but we have different options. Sometimes we collect data from record. Sometimes we make observations. Sometimes we use survey. And here they said they use web-based survey. This study, they use web-based survey. It is self-administered questionnaire. And actually web-based survey become very common recently because of easiness than taking papers and retrieving the information and writing it. So web-based survey become very common, but it have also limitation. Everything in research have strengths and advantages and have limitations. Web-based survey, we need to control to be sure that our respondents are the subject which are targeted actually by the study. Here they are talking about knowledge and attitude, and they use what is called 5-point Likert scale. That means every question related to knowledge or attitude is rated by the respondent on 5 points from 1 to 5, for example, like the example we will see in the next table. The answers are starting from strongly agree, agree, neutral, disagree, strongly disagree, and considering that strongly agree is 1 and strongly disagree is 5. So it's called 5-point Likert scale. And I will comment about some of the advantage of this one. Here, one of the statistics they use also, they use Pearson correlation. Here, at before the word conclusion, they say here's a Pearson correlation 0.08, and the other one is a p-value. P-value is not significant, but correlation coefficient, Pearson correlation coefficient is used for linear or normally distributed data. We just always try to comment on some statistic and some way of presenting data. And still we are just talking about cross-sectional studies. Here, they have table, this is study, this is about knowledge, and they have strongly agree, agree, neutral, disagree, strongly disagree, and then they have mean score. Here, the mean score is the average score computed from the responses of all respondents. Maybe one, for example, here as percentage, 48% of respondents choose strongly agree. 43.5% choose agree. So because strongly agree is coded as 1, agree as 2, neutral as 3, disagree as 4, strongly disagree as 5. So the average score is 1.64. Here, the advantage of using Likert scale is that all those are items for knowledge. Then at the end, we can have overall estimate of knowledge, as a score. And normally in presenting data, if we can use continuous data or use present that quantitatively, it is better than presenting data qualitative. And this is maybe we need to remind when we prepare survey, it is better to ask question in a quantitative way. That means if we can ask for age, for example, ask the respondent to state the actual age, better than categorize age in age group. because then we can estimate, average age, the average and standard deviation and so on. And we can compare average mean between average or the average age among male and female, average age between type of student and so on. The next table is about attitude, because the study was focusing on knowledge and attitude regarding medication error reporting. So those items are about attitude, and attitude actually represent a tendency of respondent to do certain behavior or to practice certain practice and so on. And normally we have like a positive attitude towards the issue or negative attitude towards the issue. If we are talking about attitude, one of the issues that we have to take care of is not to compute a score from positive and negative attitude together. That means, for example, if we are studying study about smoking, for example, positive attitude, sometimes they are using description like perceptions. Positive attitude towards smoking, that means the respondent have like tendency to be involved in smoking, and his attitude reflects something like saying that smoking is accepted by social accepted. If we are talking about something like smoking is prohibited or is not accepted socially, so this is framed as negative attitude. Just here, because we are talking about attitude, my point is some attitudes are considered negative, some are considered positive regarding certain issue. We should take care of this. Again here, they compute score of attitude items, and they may have overall score of attitude. Here we have another table. The table is about comparison between knowledge and attitude. They include both knowledge and attitude, and here this time they compare the score, the overall score among different categories. For example, gender, male and female, they compare the score. Here they use median instead of mean, because we present some data before, they use mean and standard deviation. Here they use median and interquartile range. We use median when the data is not normally distributed or assumed to be not normally distributed. Normally, they check normality of data. There are another many ways to check normality, but that means if we assume the data is normally distributed, we present data as mean and standard deviation. And if we think that the data is not normally distributed, we use median. This is why here they use Mann-Whitney test. Normally, if we compare mean between two groups, we use student t-test. If we compare median, we use Mann-Whitney test. Mann-Whitney test is used when the data is not normally distributed instead of student t-test. Now we come to one of the first example on longitudinal studies. Now all my previous examples were cross-section. And of course, cross-section is the most common study used in research. So we focus on it much, but now this one is longitudinal study. And again, longitudinal study can be prospective, can be retrospective. That means in terms of how data is collected. Here, this study, acute adverse effect profile of zoledronic acid in cancer patient. And we use longitudinal studies normally either to measure change over time among respondents. That means we need to make a reassessment of the same subject or of the same unit of study more than once. This is the difference between longitudinal and cross-sectional. One advantage, we can measure change in observation over time. Also, one of our advantages, we can measure outcomes of certain exposure. That means looking into dependent variable based on effect of independent variable on the dependent variable using longitudinal study. We have other type of design which is not commonly used, but very close to longitudinal is called repeated cross-sectional. Sometimes, if we want to measure change in population regarding like prevalence of disease or some change due to policy and so on, we can use repeated cross-sectional. That means we are selecting sample from population in one time, then we select another sample in after a certain time. And because the second subject different from the first subject, not the same, so it is called repeated cross-sectional, not longitudinal. But when it is longitudinal, that means the same subject are followed up to measure, as I said, change or to see what outcomes occur. Here, one of the type of presentation used in this longitudinal study is they present data in as bar graph. We have graphical presentation. This is called bar graph. Here they show male and female, the proportion of adverse drug reaction and those no adverse drug reaction. So here, one advantage of presenting data as graph, it can be good to show how differences are between groups, how they are large, how they are, and so on. This one another bar graph, but here we see something at the top of the bar, and this represents estimation with confidence interval. Here the size of the bar represents how big or small is the mean. And here we have plus, we have 11.5 plus or minus 0.9. That means the confidence interval less by 0.9 and more by 0.9. That means this upper and lower limit. So this represents the confidence interval. This is another example of longitudinal study, correlation between drug interaction induced Stevens-Johnson syndrome and related deaths in Taiwan. So here they are talking about deaths because of drug-drug interaction. So drug-drug interaction represents exposure, and deaths represent outcomes. So they use longitudinal study to show the relationship between exposure and outcome. And they use statistic, which is called correlation. They use correlation statistic to check or to test the correlation. Here, they say that this retrospective longitudinal study. So again, we come to talking about the type of data collected, can be retrospective, can be prospective. Now they are longitudinal, and this one is retrospective. We can see also longitudinal, and the data is prospective collected prospectively. Actually, if we comment on everything, we need a long time, but every slide I will comment on something. Here, this table baseline characteristic. Normally, if we are presenting something indicating relationship between exposure and outcome, or like in randomized trials, we are assessing effectiveness effect of intervention on subject, it is better to have a table when showing baseline characteristic, normal baseline characteristic. That means the characteristic before follow-up at baseline. So this table and baseline characteristic. This table is univariate and multivariate method. Here, this is regression analysis, and they use univariate. That means they are seeing the effect of independent variable on the dependent variable. So they have what's called odds ratio. Odds ratio is one of the tools used to estimate risk. That means here, for example, when we say 6, odds ratio 1.37, age 1. So that means the effect of certain sex group, the risk is higher by 37% more because this odds ratio. For example, allopurinol, that means allopurinol compared to non-allopurinol. That means allopurinol compared to other medication, the risk is high, 3.3. Carbimazepine is 0.104. That means the risk is less. That means patients who are using carbimazepine less likely to develop risk or to develop the outcome, while allopurinol more likely to develop the outcome, 3 times more likely, or 3-fold more, having 3-fold risk in developing the outcome. And they have also, of course, this confidence interval, 95% confidence interval. Again here, when we are talking about odds ratio, because odds ratio of 1 indicate no difference or no relationship between exposure and outcome. If it is 1, if it is more than 1, that means the characteristic of if occur, it increase the risk compared to those who don't have the characteristic. And when the odds ratio is less than 1, that means presence of characteristic is protecting the subject. Like, for example, if we are talking about cancer, and we talk about certain lifestyle habits, good lifestyle habits, which reduce the risk of cancer, then we will find odds ratio less than 1. Like, for example, 0.5, 0.4, 0.2, and if the exposure is risk factor in developing cancer, the odds ratio will be more than 1, maybe 1.5, maybe 2, maybe 3. And as the odds ratio increase, that means the size of the effect of this exposure is very, the probability is very high compared to the comparative group. Here, the confidence interval for odds ratio should not include 1, among the limit. Here, for example, the first one, the confidence interval 0.47 to 3.9. So the lower limit is 0.4, less than 1, and the upper limit is 3.9, more than 1. That means 1 is included in the confidence interval, and this indicates that this estimation is not significant. So we can see the confidence interval for every odds ratio here, and if it doesn't include 1, that means it is significant, this estimation. We have here p-value for univariate, for multivariate. Actually, it looks that the odds ratio presented here is for multivariate. For multivariate, the odds ratio is called adjusted odds ratio. And for univariate analysis, the odds ratio is called crude odds ratio. Univariate means what? That means they are testing the relationship between one exposure, one variable, and the outcome. And they estimate how the risk is high or low among comparative groups. This regarding one variable, this is univariate. If we are estimating the odds ratio for more than variable or all variables together once in one analysis is called multivariate. And this is actually after estimating univariate, estimating crude odds ratio using univariate analysis, we must have multivariate analysis to have adjusted odds ratio, because this is actually close to the reality. Because actually in real life, any outcome is not affected by one variable, but affected normally by a lot of variables. And here, using multivariate, that means we are showing the effect of all group of variable tested or analyzed together. Another example of longitudinal study, but this one is systematic review, actually, systematic review of longitudinal study. And this is another type of research papers. And systematic review actually is type of reviewing evidence, trying to summarize evidence collected. The evidence is presented in a lot of studies, but the number of studies addressing the same research question. If we have, for example, 10 studies, 20 studies addressing the same research question, and we want to make overall estimate out of the estimation of individual studies. This is called systematic review, but it has certain, procedure and requirement and so on. And this is not the right time to talk about it. Just here to see that longitudinal studies, we can have systematic review of longitudinal studies. Normally, which is very famous, is to have systematic review of randomized control trials, and it is considered the top evidence the top in evidence, if it is evidence from systematic review of randomized control trials. And this one is systematic review of longitudinal studies. Here, they have flow chart, because normally, as I said, for example, there's a characteristic called PRISMA. PRISMA is abbreviation for preferred reporting items for systematic review and meta-analysis. So they have criteria, certain requirement. One of the requirements that they included article and exclude article, and how article have been selected, be presented as using flow diagram or flow chart. It's called flow diagram. We see example of flow diagram before. Then now we will go to another type of studies, which is called case control studies. Here, this one is example factor associated with adult poisoning in Northern Malaysia case control study. Actually, this one is my study during my master, and I want to just make some comment about case control study. Case control and cohort studies both are used to predict the effect of certain exposure on outcome. Analytical types of study is not descriptive, and the difference between case control and cohort is that case control start with outcome, group, certain group having certain outcome, and they call it this group as cases, and another group they are not having this outcome, and they call it control. They go back into the past retrospectively to see how exposure occurred, how they have been exposed to the variables which are expected to be risk factor or associated factors. In cohort study, they start with group having the exposure and group don't have the exposure, and follow up the two groups and see in the future how outcomes develop. That means whether outcomes is more likely to develop among exposed or among non-exposed. But here it's case control, and here we have cases, our cases are poisoning cases, and our control are patient admitted to the hospital for other reason, not poisoning or overdose or drug overdose. And we were seeing how likely certain exposure, certain factors, demographic factors or social factors are more likely available among cases than among control group. So this will be risk factors. Yet to remind about the design of case control, we have study population, we select our controls and we select our cases, and then we look back to see what the proportion of exposure among cases and among control. Well, regarding this study, just now I was talking about, we just focus on some aspect. This table about advantage and disadvantage of case control generally, then I will come back to the study. One of the advantages of case control, it can obtain finding quickly. That means compared to cohort studies, because normal cohort study require long time. One limitation in cohort study is considered more preferred than case control, but it requires long time consumed. Sometimes we will see example of cohort study where the data have been collected over 20 years. But here for this study case control, data can be collected over months, depending on availability of data. So it can obtain finding quickly, can often be undertaken with minimal funding, because if we are collecting data over long time, of course we need more fund, more resources to cover the study. It is efficient for rare disease, because if the disease is rare and we are looking into the disease as outcome of exposure, if it is rare, we cannot use cohort study. For example, even if we select subject exposed to factor which is expected to be predicting the outcome or predicting the or associated with the disease, even after taking long time, 20 years, 30 years, maybe the disease not developed because it is rare. But here, in case of rare disease, we don't have option other than using case control, because even rare subject can be selected from clinic, from certain treatment center, and then compared with cohort, with control. So if it is rare disease, just we go to case control. Also, advantage can study multiple exposure. If we are talking about a lot of exposures associated with one outcome, one disease, any number of exposure can be studied using case control. It generally requires few study subjects. The sample size for case control can be less than cohort study. But there are some disadvantages. It cannot generate incidence data, incidence rate of something, because the incidence need to have data collected with follow-up to see the difference. And so incidence rate of disease, incidence rate of something, it should be something with follow-up. We can estimate incidence rate from longitudinal study, from cohort study, but from case control it cannot. Also, one disadvantage is it is subject to bias. Bias in selection, because bias is it is broad area, a lot of types of bias. We have information bias, we have selection bias. One of the bias very maybe available in case control is information bias, for example, because it is already we are selecting subject with disease and subject without disease, and we look about exposure which have been occurred in the past only, and we are asking either by survey or looking into record, where the information cannot be confirmed or accurate 100%. While in cohort study, for example, if we are talking about exposure, we start with exposure which is confirmed first, then we follow up. So here, some types of bias, like information bias, is more in case control compared to cohort. Another disadvantage, difficult if record keeping is either inadequate or unreliable, because the record can be not suitable. A lot of missing, a lot of unreliable data, conflicting data, and so on. Selection of control can be difficult sometimes. This is our study, which I showed the title before about case control study about risk factor for poisoning and drug overdose. Here, for each case, the first two patients who were admitted to the same medical ward for other illness during the same period were included as controls. And they were matched for age and gender. We have here what's called matching. Actually, matching is one of the measures used to control what's called confounding in variables when we are talking about association or relationship between variables. One of our concern is bias. We have to avoid bias or to minimize bias. Another concern is confounding. Confounding means the presence of a third variable which is having a strong relationship with the dependent and independent both together. And this variable will affect how the relationship appear between dependent and independent. And to minimize the effect of confounded variable, we use either we exclude the subject with this characteristic or we make matching. And normally, variables like age and gender are considered confounding variables in many research. So here we match by age and gender. That means when we select case and we select control for this case, it must be matched to the case in age. That means the age is comparable, and the gender. That means if it is the case is male, the control will be male also. And using matching will affect some of the statistical tests used. We will see we use a test called McNemar test. McNemar test used instead of chi-square. When there is actually, we use test, if the data is not related, I mean the groups which are compared are not related, we use like chi-square for categorical variable, and we use student t-test for difference in means between two groups, or ANOVA for difference in mean between more than two groups. But if the two groups are related, that means either because of matching or because they are the same subject, have been evaluated or assessed twice before and after, like before and after intervention. If we are making intervention and we are measuring observation for the same subject before intervention and after intervention, we consider the two groups which are before and after are related. And in this case, we use test if you are comparing between groups, we use McNemar test instead of chi-square. If we are using means, comparing means, we use Bayer t-test instead of t-test or student t-test. Actually, you cannot go into every slide. Yes, I will move to focus on certain point. Here it is used Mann-Whitney. This Mann-Whitney is used for certain comparison, which instead of student t-test, because data is not normally distributed. Here in this slide, it's called about it is about the sample size calculation. Normally, for studies like case control, cohort, and randomized trials, we need to calculate sample size from the beginning. And normally sample size calculated based on the minimum size that can show the minimum difference possible between the comparative groups. Here we use standard calculation at significance level of 0.05 and power of 80% based on an odds ratio of 2, gives sample size of 100 cases and 200 control. Here we use McNemar test for and binary logistic also. In this paper, we have crude odds ratio, we have adjusted odds ratio, we have confidence interval. We use what's called backward stepwise logistic regression. This in multiple multivariate analysis called backward stepwise logistic regression. That means all variables included in analysis together, and every time we remove one variable and see the overall set of variable, how they are consistent together or not, till we reach a set of variable which are consistent together and give like stable relationship. Yes, this table is about demographic characteristic of cases and control. This considered like baseline data of cases and control. And actually we did one comparison for subjects which are refused to join the study because one of the type of bias that we are afraid from of such types of studies is called non-response bias. That means if we have subjects refuse to participate in the study, but those all subjects have certain relationship between them, that means they are not normally distributed between the groups or comparably. So there will be some problem, or we will be afraid of non-response bias. We compared, unfortunately, fortunately, there was no significant difference between characteristic of respondent and non-respondent. Yeah, univariate analysis. We use McNemar test. Also, we have here multivariate analysis. We have adjusted odds ratio. Then another example, another paper, case control study. This one about adverse drug event related to hospitalization in persons with neurodevelopmental disorders. It is, this one is cohort, so it's not case control, retrospective cohort study. So now this is example about cohort study, and this retrospective cohort, we will see that cohort studies is two types, either prospective cohort or retrospective cohort. Prospective cohort, we can just call it cohort study. If we say it is cohort study, it is prospective. That means we start recruiting subject exposed and subject not exposed to the characteristic which is expected to be affecting the outcome or the disease. And then we follow up in the future. If the latency period between exposure and development of outcome is long, we need to follow up for a long time. It can be 20 years, 30 years, and so on. But one advantage, if we use retrospective cohort, we can save time. Retrospective cohort, that means we can go back in record, if we have good record, like 20 years back in record. In some Western countries, they have good record. So they can have good data for tens of years. Then they can recruit subject exposed to certain factor in the past, and recruit another group not exposed, and come back to see in the present time what outcome have been developed. And this is called retrospective cohort. One of the issues I want just to focus in this study, here they present what is called RR. RR is relative risk. Relative risk. Actually, the two common types of tools to measure relative, risk, estimate risk, are relative risk and odds ratio. If we are using case control study, we don't have options. Just we have to use odds ratio. If we are using cohort study, we can use relative risk. And relative risk actually is the more close estimation to the reality, while odds ratio is considered approximate estimation of the relative risk. So that means this is one advantage of cohort study, because we can calculate relative risk, which is more close to reality, better than relative risk, or as sometimes they call rate ratio or relative risk. This relative risk is better than odds ratio. One advantage in cohort study, we can estimate relative risk. We are minimizing some types of bias, because we can be sure that exposure occurred and that outcomes occurred. We can avoid missing data. So a lot of advantage in cohort studies. But generally, when limitation cohorts require long time, unless it is retrospective cohort. But retrospective cohort require good record, which is not available everywhere. Here, for example, this one is 20-year follow-up of statins in children with familial hypercholesterolemia. This one, 20-year follow-up. This is prospective cohort. This is prospective cohort. So I will go fast. This one is flow chart or flow diagram to describe how follow-up have been conducted and baseline selection and so on, and over 20 years. And here they have characteristics at baseline and at follow-up. I don't want to stop. Now we have example of randomized control trial. Randomized control trial. This one is randomized control trial. As I said, randomized control trial consider the gold standard of designs, which is POP in evidence. Randomized trial strengths include first, because there is randomization, which will reduce bias, and there is also normally blinding. Also, blinding is different levels, maybe single blindings, double blinding, triple blinding. As we have more blinding, it will be preferred. So blinding and randomization, and also we have control of other variables, co-variables, control of co-variables. So this is strength of randomized control trials. This makes the validity, internal validity of finding is high of randomized trial compared to other studies, especially observational like cohort and case control. But at the same time, because of control because of restrictions in selection of criteria, inclusion, exclusion. The external validity is low relatively for randomized trial compared to cohort and case control, which are observational studies. External validity is low. External validity means extrapolation, extrapolation of what we found or what we find in the study to the population. How likely the observation in the study already present in the population. Randomized cohort study and case control study, which are observational studies, are considered good in external validity. This is why normally if we want to look into evidence about effectiveness of medication or safety of medication, it is preferred that we get evidence from different types of studies. That means including observational, experimental, and so on. Not just to take the evidence from one side, from experimental only. Experimental are good in internal validity, specifically randomized trial, very good, very high in internal validity. That means what finding have been discovered or identified by the researchers are actually true. That means the study was able to measure what it was intended to measure. And that also means that the bias is minimized. But the extrapolation is a reflection of how the subjects look close to what is found in practice. I not want to go more deep, but just I give a brief overview about randomized trial. We have this one is a flow diagram of subject selection and follow-up. As I said, it is required for consort flow. This consort flow diagram is a requirement. I think we can stop here, and if you have any question, then we can take the questions, because I tried to go into variety of studies from research papers. We talk first about cross-sectional studies. We provide many examples. We provided examples on longitudinal study, also examples on case control, cohort study, and finally, randomized controlled trials. And in between, we make comment on some statistical tests and some types of analysis and how data are presented and so on. So we can stop here and look into your questions. So any questions?
Thanks a lot, Doctor, for your amazing presentation.
Thank you very much.
Everyone, if you have any question, just write in the chat box, or you can raise your hand and ask directly. Doctor, we have a question from Ahmad. He is asking, how can I write research proposal for master?
How can I write research proposal for master? Okay. The first point to write proposal or to conduct a study is to conduct literature review. First of all, is the topic already decided or not? Because we have to identify topic suitable for research at the beginning. Normally, we, especially in practice research, it's called applied type of applied research. We conduct research to answer questions related to solve certain problems. We have to identify research problem which deserve being studied. Then we have to read the literature about this topic. Sometimes we have idea, like vague idea about certain topic is important for us, but we don't identify the scope, specific scope of the study. We need to read the literature. Reading the literature will identify first what is available in the literature, what knowledge already is known about the topic. This is the first one. The second one, what is the gap in knowledge? What is the gap in knowledge? What are the limitations in the previous literature? From this we can start, because either we focus on the area where there is a gap in knowledge, or where there was some limitations in the studies already conducted. Maybe there are a lot of studies in the topic, but there were some limitations, like small sample size, like using tools which are not valid, or not methodology which to use better tool, different methodology, different types of way of analyzing data. So by reading the literature, we will know how, what approach we have to select. Also, reading the literature will make us able to estimate, for example, sample size, how much sample size we need based on literature. Even if we want to calculate sample size, some parameters we must have, we need to take from literature. Either we conduct biological study or take from literature. So the advice is for every research is good reading of literature. By reading literature later on, even after conducting the study, we will be able to discuss our finding, to know how our finding affect the available literature and so on. But if somebody because he's lazy, or somebody don't have time, he want to just conduct a study without reading literature very well, the study will be full of flaws, full of limitations and problems, and even maybe make a study and collect data and then find the value of finding or value of your study is very low, because already conducted study on something already studied extensively in the literature. So we need to read the literature. Then after that, we can write the proposal. Proposal as writing skills is something else. This is something else. And requirement of structure of proposal, this depends on the institution. Length of proposal depends on institution, and so on. We have to find topics with priorities, like something urgent, something not studied very well, something that can find support from policymakers, something that we can get easy fund for it, and so on. This is briefly. So I hope that my answer is helpful.
Thank you so much, Doctor. We have another question. What are the different types of data analysis that are there?
Different types of data
Analysis.
Data analysis.
Yeah.
In general talk, we analyze data either descriptively or inferentially. Descriptively means we describe what we found, or what we find or observe in our sample. This one just descriptive. That means like showing frequencies, percentage, mean plus standard deviation, or medians plus interquartile range, or present the data graphically to show the pattern of data and so on. All this descriptive. Another one is inferential, making inference. That means from sample, we want to describe the population actually, not the sample. But we describe the population based on what we observe in the sample, and it's called inferential statistic. It includes estimation, like estimation of disease prevalence or estimation of incidence rate of disease, or testing hypothesis. Hypothesis about, like when we say new drug is more effective than another drug in practice, or more effective than placebo. So this is like hypothesis, consider hypothesis we want to test. And we the data analysis will be inferential, but the design itself is something different. The design should be chosen based on type of question, of research question, what we want to do, what objective we want to achieve. For example, if we want to estimate prevalence of disease, we can use cross-sectional study. If we want to estimate incidence rate of disease, that means the rate of occurrence of new cases, we need to choose a study with follow-up, like longitudinal or cohort. If we want to test relationship between variables, exposure and outcome, dependent and independent variable, we have to choose analytical design, like case control or cohort. If we can take or undertake cohort study, is preferred than case control, but normally cohort study is difficult. It requires long time. It requires more fund, more resources, and so on. This is why case control is maybe preferred choice, especially for students. To use case control, we can save time, and for rare disease, it is preferred just to go to case control. If you want to test something like effectiveness of medication, prediction of factors responsible for certain disease or certain adverse drug reaction and so on, or safety of medication, or effectiveness of intervention, we can use experimental study, like randomized control trial. If we are talking about experimental study, we should go first to randomized trial because it's preferred. But sometimes, if we cannot conduct randomized control trial, we go to something lower than randomized control trial. Like, as I said in the beginning, we have pseudo-randomized trial, we have quasi-experimental, we have non-randomized trial, we have before and after study, and so on. So this is in general. So any question? Another question, please.
It seems that we do not have any other question. Thank you so much, Doctor, for joining us today and for fruitful information on the methodologies and study design. It was very useful.
Thank you very much for you, Maria, Muhammad, and thank you to the International Pharmacy Student Federation for inviting me to give this presentation. And I hope that I was able to provide something useful. And thank you, and wishing you all the best in your research work and future.
Thanks a lot. And thanks also to all participants who joined us today. Actually, we will have also many other webinars in the upcoming weeks, and also we have our second session tomorrow, which will be on research ethics. So stay updated to us and join the WhatsApp group so that you can follow more easily with us. And also we'll have another sessions on data analysis and writing research papers. So all questions you asked today will be covered in different separated sessions. So thank you so much for attending today, and good night.
Good night.